Hi everyone, today we'll look into the next best alternative to the Kmeans clustering, Gaussian mixtures. Also, understand why GMM is the next best clustering model by comparing it with the Kmeans. Kmeans uses an iterative approach known as expectation maximization, EM in short. The process of EM includes randomly assign some cluster centers, repeat step 3 and 4 until it further can't be converted. EM assign points to the nearest cluster center. M step set the cluster centers to the mean. In simple words, determine the k value by Albert method and assign k, the number of clusters. Randomly assign each data point to the cluster. Determine the cluster centroids. Then determine the distance of each data point to the centroids and reassign each point to the closest cluster centroid based upon minimum distance. Calculate cluster centroids again. Repeat the steps 4 and 5 until we reach the global optima where no improvements are possible. Now there are common drawbacks of K-means. K-means might perform slowly for larger dataset because each iteration of K-means must access every point in the dataset. Thus, the algorithm will be relatively slow with the increasing number of sample data. One of the drawbacks of K-means is the number of clusters must be selected beforehand. This is a common challenge because K-means cannot learn the number of clusters from data. However, I fixed the issue of determining the number of clusters K for the K-means. You can check out in my article AutoAlbo or visit the pypi.org and search the AutoAlbo. Now let's understand the Gaussian mixtures. What is expectation maximization? EM, that is expectation maximization, is a statistical algorithm for finding the right model parameters. We typically use EM when the data have missing values. In other words, the data is incomplete. These missing values, that is variables, are called latent variables. EM tries to use the existing data to determine the optimal values for these variables and then finds the model parameters, and based on these model parameters we update the values for the latent variable. It includes two steps. Each step, the available data is used to guess the values of the latent values, and the M step on the estimated values from the E step updates the parameters. Expectation maximization is the base of many algorithms including Gaussian mixture models and K-means. Let's get into the hands-on with the GM models to find the clusters. A Gaussian mixture model GMM attempts to find a mixture of multidimensional Gaussian probability distributions, and because GMM contains a probabilistic model, it is possible to find the probability of the given cluster belongs to. GMM helps to overcome the lack of flexibility in the cluster shape of K-means, which we will see later during the video, and also overcomes the lack of probabilistic cluster assignment. However, GMM is a bit difficult to interpret the results. K-means primarily uses two parameters, the number of clusters K and the centroids, and GMM uses three parameters, the number of clusters K, mean, and the cluster covariances. We will create a dummy dataset. Before we have our K-means and GM, we will create user-defined function to plot, to visualize the results. Now let's fit the K-means model with n underscore clusters equals to 4. This is the plot. Now quickly we will also do the same with the Gaussian mixtures with n components equals to 4. We can clearly notice the shape of K-means and the shape of GMM. K-means are restricted to a circular shape, and GMM is a probabilistic model. We can also get the probabilities using predict underscore proba. Here's the results, the table. all the 4 clusters along with their parameters. This is very helpful and gives the flexibility to filter out the results based on a threshold. That's it. I hope you will find this article very useful. If you would like to know more about the advanced types of clustering, follow my other article, A to Z Clustering. I have provided the link in the description below. Thank you for watching. Enjoy machine learning.